There we go. So this is not the Pythagorean theorem. This is the converse of the Pythagorean theorem. So basically, what a converse is this. Let me show you a little bit of. Oops, I got to change my pen. I forgot to change my pen. There we go. All right, everybody's listening, right? Aspen, you listening? I don't think so because I hear your voice. All right. So here's the thing you learned back in, I don't know if you learned this in geometry or not, but this is like logic stuff. We use P and Q for logic. So if P, then Q. Actually, forget the arrow. Let me put the word in there. If P, then Q. Anybody remember seeing this in math class at any point?
Yeah.
Okay. We usually write it like this. We simplify it. This means if P, then Q. That's why I put the arrow earlier. Okay? So anyway, if P, then Q, what does that mean? It means, on the Pythagorean theorem, if you have a right triangle, so if you have a right triangle, then what's true about the sides of the right triangle, according to the Pythagorean theorem? Then A what? Plus B squared equals C squared. Okay? That's the statement itself. Now, when we talk about the converse of a statement, we switch around the P and the Q. Right? So instead of saying if it's a right triangle, then A squared plus B squared equals C squared, what do you think we're going to do now? We're going to say if what? If A squared plus B squared equals C squared, then it's a right triangle. Okay? Everybody see that? So let's see how we can use it. So what they're going to do is they're going to give you a triangle. Let's draw the triangle. They do it. I'll just do number 9 for you. Okay, this is the first one on the second half of the worksheet. Oops, I don't want it all crooked. Let's try that again. There we go. And then let's go up like this. Why are we talking while I'm just drawing a triangle? Just sit and just watch. Okay, it's not a free pass to start talking when I start drawing stuff up here. I don't understand how that got started. 10 years ago when I used to teach math, it didn't seem like that happened as often. This year, it's absolutely crazy. So watch. What if I had a triangle with these sides? Okay. Now, I shouldn't actually have put a right angle there because I don't know it's a right triangle just yet. It's a triangle. Would you agree? 3 sides. And here's the 3 sides of the triangle. I want to determine, is this a right triangle? Well, it looks like it is according to the picture, doesn't it? All right. But I don't know for sure. It might be like 89.999 degrees. Does that make it a right triangle? No. All right. So I'm not really sure. So how can I figure it out? Well, this is what we're going to do. If I take, again, these sides right here represents the legs of a right triangle. But if I just talk about any triangle, the A and the B represent the 2 shortest legs, or the 2 shortest sides, okay? And the C represents the longest side. Everybody follow me on that? Okay, and it doesn't matter which one the A and the B is. They're the 2 shorter ones. So which are my shorter sides right here? So this would be the A, and this would be the B, correct? All right, and then obviously this would be the C. So I want to see if it's a right triangle. So how do I know if it's a right triangle? If it fits this little formula right here, if this works, if I take the A squared and I add it to the B squared, it should equal what? C squared. If it doesn't, then is it a right triangle? It's not. Now, we will be able to figure out after we do this what kind of triangle it is, okay? So if it's not a right triangle, we're going to figure out, is it an acute triangle or is it an obtuse triangle? You know what acute and obtuse are? Yeah. Acute means it's less than 90, okay, and obtuse means it's bigger than 90. All right, so we'll get to that in a second. Let's just see if this is a right triangle or not, okay? So what do? Take the 2 smaller sides. What are they? 9, and I square it, and I add it to what? 12, and square it. So I take the 2 shorter sides, and I see if it's equal to. I don't know if it's equal just yet. I'm going to put a question mark there. Is that all right? Yeah. And then I'm going to put a 15 squared. Let's see if this actually works. What's 9 squared? 81. What's 12 squared? Okay. What's that added up? That's a 5. That's a 225. Is that right? 225. All right, now let's see. I'll put a question mark there. Let's see if it's equal to 15 squared. Does anybody know what 15 squared is? It's 225. How about that? So are they equal to each other? I can get rid of the question mark now. I can say they're equal. I'll put a little check mark. And what is the question? The question says, is this a right triangle? So is it a right triangle? Yes. Yes. It's a right triangle. You can write if you want to. This is how you show it, though. All right? You show that the two smaller sides squared and added up equals the longest side squared. If that's true, then it's a right triangle. Is every single triangle going to be a right triangle? Obviously not. So let's do one. And I hate to give it away, but this one is not going to be a right triangle. Okay? It's not 10. 10 is a right triangle, but you have to show why it's a right triangle. Let's do 11. I'll tell you right now, hate to spoil the fun, but number 11 is not a right triangle. Okay? I'm going to make it look like it's a right triangle, but it's not. Okay? So this side is 9. This one is 11. And this one is the square root of 115. Which doesn't necessarily mean this problem is a lot harder. Because remember what we're going to do to it. We're going to square it anyway, right? And so really it just gets rid of the square root. So that actually kind of makes things a little easier for us, doesn't it? So don't get scared when you see a square root as one of these sides. So what are the, first of all, let's figure out what square root of 115 is. What's the square root of 115? You got a calculator right in front of you. Punch it in. Punch it in. What's the square root of 115? Don't say 115. What's the square root of 115? Quick. 10.7. Okay, that's all we needed to know. So this is about 10.7. So which ones are our two shorter sides? The 9 and the square root of 115. Everybody see that? Yes? Anybody here? Guys working on your laptops? Are you taking good notes on your laptops? What are you doing? Watching Netflix or what are you doing? It seems like you're doing other things. So everybody look up here. So what we're going to do is take the two smaller sides. What are they? The 9 squared and then the square root of 115. We're going to square that. And we're going to compare it. I always put a question mark here. I don't put equals because I don't know if it's equal just yet. So that's why I put a question mark. We're going to see if it's equal to what? 11 squared. So let's see. What's 9 squared? 81. Plus, what's the square root of 115 squared? 115. That's easy because the square root and the square cancel each other out. Somebody do that math for me. What's that? That's a 6 and that's a 8 and 11, which is what? 19? Is that right? Did I do that right? Okay. Now, let's see if this is equal to this. What's 11 squared? 121. Are they equal to each other? No, they're not equal to each other. So is this a right triangle? No, it's not a right triangle. But I'm sure you're dying to know what kind of triangle that is. Well, I'm glad you asked because I'm going to show you. I'm going to give you another little formula. This time, instead of saying a squared plus b squared equals c squared, I'm going to switch. I'm going to put the a squared plus b squared on the right and put the c squared on the left. All right? So if c squared is equal to a squared plus b squared, what kind of a triangle is it then? It's a right triangle. I'm doing this for a reason, okay? I'm putting the c first for a reason. I'll show you why in a second. Now, I'm going to show you two more things, and they kind of make sense if you look at it. So if I take c squared, and if c squared is greater, okay, bigger, the number is bigger than the a squared plus the b squared, what do we know about angles that are bigger than 90? They're obtuse. So if you take the longest side and you square it, and if it's bigger than the other two sides squared and added up, then this is going to be what kind of a triangle? An obtuse triangle. Okay? So if they're equal, it's a right triangle. If the c squared is greater than the a squared plus b squared, it's an obtuse triangle. So take a wild guess. If c squared is what? Less than. Okay, we had greater than. If it's less than a squared plus b squared, what kind of a triangle is it going to be? It's going to be an acute triangle. You with me so far? Okay. So let's do this. Let's do number 15. This is right from your homework. So I'm doing 2 problems right from your homework. So number 15 says they give you 3 sides. They actually draw the triangle for you, but they don't really have to draw the triangle. I'm just going to put them in order. So we have a 9, we have a 12, and we have a 17. Okay, those are the 3 sides of my triangle. Everybody getting this?
Yeah.
So what we have to do is determine, is it a right triangle, is it an acute triangle, or is it an obtuse triangle? That's what we're trying to do. You with me on what we're trying to do? Okay, okay, these are 3 sides of a triangle. And I got to figure out by those numbers, just from the numbers. I'm not really looking at a picture. I'm just looking at the numbers, and I got to figure out, is it a right triangle, is it an acute triangle, or is it an obtuse triangle? So how do we do that? Well, this is what we use right here. We use these little formulas. Okay? So first of all, we take the C. Which one is the C in this situation? It's the 17, because it's always the biggest one. So this is the A and this is the B. So let's compare them. Let's take the biggest side, which is 17, and we're going to do what to it? We're going to square it. And then we're going to compare it. I'm going to put a question mark because I don't know if it's equal, less than, or greater than. Okay? Not yet. Then I square and I add up the other 2 sides. So I'm going to take that 12. I'm going to square it. I'm going to take the 17. I'm sorry. Let's do it in order. Take the 9 and square it, and take the 12 and square it. And now what we're going to do is we're going to compare. Let's see what 17 squared is. Somebody do that. What's 17 squared? 289? Didn't we already do that one? Yep. 289. And then what's this going to be? That's going to be 81, and this is going to be 144. Didn't we already do that? That's a 5, and that's a 22. That's 225. So now let's compare. Compare 289 to 225. What is 289 compared to 225? It's greater than. So I put a greater than. Since I know that the C squared is greater than the A squared plus B squared, what kind of a triangle is this? It's obtuse. So now I know that this is an obtuse triangle. And that's my answer. It's really pretty easy. If you know Pythagorean theorem, then you can figure out what kind of triangles are you dealing with, okay? You can take any 3 sides, all right, and figure out if it's a right triangle, an obtuse triangle, or an acute triangle by applying these 3 things right here. It's really not much different than the regular Pythagorean theorem, is it? Okay, except they're just not equal, okay? Sometimes they're greater, sometimes they're less than. If the C squared is greater, it's obtuse. If the C squared would be less than, then guess what? It would be what? What kind of triangle would it be? If C squared was less than, it would be acute. That's right. And if C squared was equal to the A squared plus B squared, then it would be a right triangle. And that's all there is to it. It's not so bad, is it? Everybody good? Anybody still awake? Got a couple people still awake. That's good, I guess. All right, that's enough. So that the second part of that worksheet is going to be due whenever you come back. All right.